Let's do some more examples of finding x and y intercepts of quadratic functions, in other words, parabolas. Algebraically determine the x-intercepts and y-intercepts for each function. X-intercepts means y equals 0, y-intercepts means x equals 0. Use a calculator to round any irrational values. That just means square roots that don't fully simplify. So let's try this. First, I'm always going to start with y-intercepts because they are always easier. So y-intercept just means plug in x equals 0. So everywhere there's an x, I'm putting a 0. So we have 2 times 0 minus 7 quantity squared. Well, that's just 2 times negative 7 squared would be 49, which is 98. So that means the y-intercept is the point. So remember, intercepts are points, 0, 98. So y-intercept, just plug in 0. It's sort of the starting value, or where it crosses on the y-axis. X-intercepts, though, involve a little bit more. We need to set y equal to 0, and then solve for x. So 0 equals 2 times x minus 7 quantity squared. And now we have to decide the best way to algebraically solve this. So what I'm seeing is just one thing being squared. That means I can use the square root property, just square root both sides. I don't need the quadratic formula. Multiplying this out and then using quadratic formula is a whole lot of extra work that I don't want to mess with. And I can even just divide both sides by 2 here. And then I just get 0 equals x minus 7 quantity squared. And then I can square root both sides. Now normally, anytime you use that square root property, you have to use that plus or minus. But 0 is the one exception. I can't have negative 0 or positive 0, it's just 0. So the squared just goes away. We get 0 is x minus 7. So if I add 7 to both sides, 7 equals x. So that makes the x-intercept the point, and again, intercepts are points, 7, 0. So we have the y-intercept is 0, 98, and the x-intercept is 7, 0. All right, let's try it again. This time the function is a bit different than, at least at first it looks different. Let's see if algebraically it's different. Y-intercept, I just plug in 0. J of 0 is 0 minus 0 plus 10. So x equals 0 makes this just 10. So the y-intercept is the point 0, 10. Oops, sorry, I'm off screen there. Okay, well that's easy. Y-intercepts usually are pretty easy. X-intercepts, however, always take more work. 0 equals 4x squared minus 5x plus 10. This equation has both x squared and x. And what that means is that we have to use quadratic formula. All right, we can't just get the x squared by itself and square root both sides. We can't just get this x by itself. There's 2 pieces and we need to deal with both using the quadratic formula. For quadratic formula, you always need equals 0, but for x-intercepts, we got that. So let's just plug it in. If it helps you, always, you can always write out what a, b, and c are. Make sure b is negative 5, not positive 5. So we got x equals the opposite of b, so that would be positive 5 plus or minus. And make sure when you square a negative for b squared, it becomes positive, please. I see way too many mistakes with that. So b squared minus 4 times a times c, all over 2 times a. All right, so now we're going to do what's inside the square root first. And we can just use a calculator if we want. So I would just type 25. I like to do the squaring in my head when I know what it is, b squared, minus 4 times 10 equals negative 135. So 5 plus or minus the square root of negative 135 over 8. Now, we've talked about imaginary numbers, so we should be able to, write this with an I. But for finding x-intercepts, what this tells us, since this is not a real number, that means that there are no x-intercepts. So these are actually, the two problems we just did give us sort of a couple interesting examples, because on the previous page, we always got 2 x-intercepts. This one, we only have 1. Let me just say that this is 7, 0. So what that means, if you only have 1 x-intercept on a parabola, is that the graph just sort of barely touches, and that x-intercept is the vertex. Whereas with this parabola, it's not even going to touch. It's going to stay above the x-axis, and that's why there are no x-intercepts. So these two examples give us sort of these weird cases where you don't get 2. You can either get 1 x-intercept or no x-intercepts. All right, let's see what a word problem looks like in this section. A rock is thrown into the air off of a cliff. Turns out when you throw things, they make parabolas. And so a lot of the word problems we're going to see are about throwing things. It has an initial velocity and the height. Really, what's important is they give you this formula. And then you can look and see, oh, the initial velocity is in the formula. The height of the cliff is in the formula. So we don't need those pieces separately. They're already part of the equation we're being given. But what is important is to know that h is height and to know it's in meters. And then t is time. And you can see they say meters per second, so that means time must be measured in seconds. So that's always important, is to know what the variables mean. Then it says, what is the maximum height of the rock? And I better draw a picture. All right, so here's a cliff. Here's Amy on the cliff, and I'm throwing rocks into the ocean, because why wouldn't I? All right, and then it goes into the water or whatever. Okay, so this makes a lovely parabola. All right, my drawing's great, everything's perfect. All right, what we want is maximum height. Max height. Well, anytime we're going to see maximum in chapter 9, that's going to be about the vertex. So we need to be on the lookout for words like maximum or minimum or highest or lowest, because those are going to be the vertices of our parabolas. Well, hopefully you remember how to find a vertex. The formula is negative b over 2a. So we look on here, the b is 10, so that's negative 10 over 2 times a is negative 4.9. So this is negative 10 over negative 9.8, and we use a calculator. You can even maybe double check that I did 2 times 4.9 right. So that's 10 divided by 9.8. I'm not worried too much about the negative signs, because a negative divided by a negative makes a positive anyways. So I get approximately 1.02, and this represents seconds. Right, because it's an x value, I called it t over here. The formula called it t. Maybe, good thing I used an erasable pen. It's not a huge deal as long as we understand it's the independent variable. It's the seconds that we just found. That's not what they asked. Well, it's the second question. When did it reach the height? When? After 1.02 seconds. What is the maximum height? Means I'm supposed to plug into this function. So that would be h of 1.02. And wherever there's a t, I'm going to put my t value that I just found. Negative 4.9 times, and it's positive 1.02. 1.02 quantity squared plus 10 times 1.02 plus 50. Definitely want a calculator for this one. So 4.9, make it negative, then times 1.02, either squared button, or if you're on your phone and trying to do it quick, remember on a phone you just turn it to the side for squaring, or you just multiply times 1.02 again, plus 10 times 1.02 plus 50 equals. And that's what I got. So let me write it down and then we'll figure out what this means. I got 55.102. A lot of 102s happening. What this is the height in meters. So this was the maximum height because, you know, my arm isn't that strong. So I started on a 50-meter high cliff and I just threw it up 5 meters, and then it has a long way to fall down, but my initial upward movement wasn't, you know, as high as where I already was. Hopefully that makes sense. Let's try the next one. How long does it take for the rock to hit the water? All right, so on my picture, what that's talking about is the x-intercept. That means where y equals 0, or the height equals 0. So when we talk about hitting the ground or hitting the water in these kind of problems, they're talking about setting the height to be 0. All right, so let's do that. 0 equals negative 4.9 t squared plus 10t plus 50. Well, x-intercepts we've seen are harder to find. And especially when you have both t squared and t, that means we need the quadratic formula. I can't just square root both sides. I gotta use it. In this quadratic formula, a is negative 4.9, b is 10, and c is 50. All right, let's do it. T equals negative b plus or minus the square root of 10 squared is 100 minus 4 times negative 4.9 times 50 all over 2 times negative 4.9. All right, always do what's inside the parentheses first. Be on the lookout for a negative times a negative. This is going to make a positive. So you could even type it in the calculator as a plus. I might do that. 100 plus 4 times 4.9 times 50. All right, so I'm getting 1,080 under here, but make sure you can get that on your own too, because a lot of times it's just being careful with typing it in the calculator. So negative 10 plus or minus, ooh, and I might even want to do a square root. Let's see if 1,080 has a nice square root. It does not, so I'll leave it. Over negative 9.8 is 2 times 4.9. And maybe we could simplify this, but they're going to want an approximation anyways, since this is a word problem. So we just need to take negative 10 plus the square root and divide, or negative 10 minus that square root. So let's do it. We got 2 different options. So let's say, yeah, this was the square root. So I'm just going to subtract 10 equals divided by 9.8 negative equals, and I'm getting negative 2.333. Let's do the same thing. 10 negative minus 1,080 square root equals, or put parentheses around the top, right? It's the same kind of idea where you have to do the top of the fraction first and then divide by 9.8 negative. And so the other answer is 4.374. Please round, right? Look to the next decimal place to decide what to write in that third decimal place. So what in the world is this? We were supposed to answer how long does it take for the rock to hit the water? And we found two answers. The negative answer we don't need. Really what this means for the picture is that, like, if we traveled back in time, there would be another x-intercept down here. But I'm not traveling back in time before I got on this cliff. So we only want the positive answer, and it's in seconds. So the rock will hit the ground after 4.374 seconds.